Now let's get started. What makes discrete math, what makes combinatorics, what makes applied combinatorics different from other kinds of mathematics? And especially, what makes it different from the calculus? Here's a starter problem. I ask you, are those two sequences the same? I see several of you shaking your head, and I'm getting the idea that you think the answer is no. But let's suppose that there is an argument, and he says, yes, they're the same, and she says, no, they're different. How do we decide who is correct? Both students are just making an assertion. Yes, they're the same. No, they're not. Who wins? How can we referee this match and decide collectively that one of the two is right?
We have to put it to the test.
What do you mean put it? He said we have to put it to the test. What does it mean to? I'm looking, I understand you, but I'm looking for a different answer. Yes?
And if otherwise it proves they are.
So what I'm hearing you say is that the person who wants to claim that they're different has an easier task. That individual simply says, from left to right, look at the 17th position. They're different. I made up the number 17. Is it clear what I'm saying? Now, the person who claims that they're the same has a somewhat harder task. That person has to say, all right, let's work together. Let's take the first term. The first term is a 1 in both sequences. Now let's look at the second term. They're the same. And you have to go through every entry. Now, if that loop is completed without a violation, then the first person has verified their claim that the sequences are the same. A simple problem. Let's make it a little harder. I have 2 DVDs that are both installation discs for the new Microsoft operating system, Windows 10. They were both created from the same ISO file using a high-quality burner, but I want to be assured that those 2 disks are indeed identical. That's the same problem that we just addressed, but it's a little bigger in scope, isn't it? How do you do this? How do you do this? If some genius somehow knows that they are different, that genius could say, check a certain sector, check a certain file location, and right there, the 2 disks are different. And if you have the ability to access a specific location in the disk, you could do that. That's just like in the first problem, someone saying, look at the 17th entry. But how do you verify that bit by bit by bit, 2 DVDs are the same? Can anyone do that? Can you sequentially look at every location in a 3.7 gigabyte file and be assured that every entry is the same. Can anybody do that? And I say anybody, I mean, I'll include the electronic bodies. With your best computer, can you do that? Maybe not. Okay. What fairly advanced computer science topic are we beginning to address right here? The notion of a hash. You've heard of things like MD5 sums and SHA-1 sums, and now SHA-256 and even SHA-512 sums. These are methods that hash a huge file down into a little string. They're not exact. They work in a probabilistic setting. If two disks hash via an MD5 or an SHA-1 or SHA or one of these other sums to the same string, then they are almost certainly identical. I said, almost certainly. You would bet your life on it, but you might lose. But nobody tests every bit of 2 DVDs to see whether or not, bit by bit, they're identical. That we don't do.